Good afternoon, everyone. I'm Greg Ulmo with Key Performance Ideas, and I would like to welcome you to our webinar, Mastering MDX for Analytics and Reporting. Today's webinar will be presented by Jennifer Hanks. Jennifer Hanks is a finance and accounting and IT professional of 15 years. She has spent the past 10 years working with financial systems, including Essbase, Hyperion Planning, and PBCS. She brings a unique perspective of understanding the business side of requirements, the technical data sources and flows, and an understanding of how to bring all the pieces together to provide an efficient, targeted solution. A recognized thought leader, I'm happy to welcome Jennifer, who just received the Top Speaker Award at Kscope 17 for this very presentation. Welcome, Jennifer.
Thank you, Greg. And welcome, everyone. So today we're going to talk a little bit about MDX and reporting. So for the agenda, it looks long, but it won't be too bad. We'll speed through some of these sections and get to the good content at the end and spend the time on that. So we're going to talk a little bit about what is MDX, what are some of the advantages of using MDX, but some of the things you should also consider before doing so. Talk about the MDX syntax and functions and how you use that in reporting. We're going to talk about calculated numbers and name sets, execution, solve order, how to suppress numbers in your report, how to execute those MDX queries once you create them, how to use MDX and Smart View together, how to track your MDX queries, and that will be it. So let's go ahead and get started with what is MDX. So MDX is the query language for OLAP databases, so it's not just used with the Hyperion products, it's also used with Oracle BI, Cognos, Microsoft Analysis Services. Obviously, we're going to focus on the Essbase use, but it's the method for querying and manipulating the multidimensional data that is housed in these applications. So what are some of the technical uses for this? So you can use it as member formulas in ASO cubes. So there's a lot of training out there on that. You can also do reports using the MDX script editor, and you can also pass those same scripts in a MaxL shell to run those MDX statements. And those are really the two that we're going to focus on today. So you can query data with these MDX scripts from both BSO and ASO cubes. And it's written very similar to SQL, where you're selecting numbers from a database and then you're using a where clause to determine your parameters. So what are some of the advantages of MDX? When you compare it to some of the other options like report scripts or even FR, you can display both the member name and the alias when you write your MDX scripts. You can display your member attributes and your cell properties. You definitely get a much richer set of functions to work with than you would with, say, a report script. You can sort and restrict both your data and your metadata. You can use calculated numbers that don't have to exist in the outline, which can be very, very helpful. You can transfer some calculations to the query. You can query the data and the metadata using the same syntax. And then, it can be automated and scheduled. And really, when it comes right down to it, it's faster than writing a report script or doing a data export calc script. Before you start going down the road of doing the MDX query, though, some of the things you really do want to consider is, although there is a much richer set of functions, there isn't a very rich set of formatting options. So you're not going to get page headings. It's not going to produce a super pretty report like you would get from financial reporting. So it's definitely just a data output for you. There is a special coding language to learn, and there's always a learning curve with that. There is a size limitation of 64 axes, so the size of your slice can only be so large. So if you're trying to do a really large amount of data, this might not be the tool for you. It is not an end-user interface. You're going to be using this either in Essbase Administration Services, EAS, or you are going to be executing it from a MaxL shell. You can use it within Smart View, but you would have to write the script. Within there is no interface to help you with writing that script. And then it's not an interface for database exports or large production reports. So again, we do have a limit on the size, and the larger the slice that you're trying to query, the longer it will take to run. And then very important, you can use substitution variables within those scripts, but you cannot use environment variables. So just some things to consider before you get started to make sure that you're using the right tool for the job. Talking a little bit about the syntax of MDX. First of all, it is not case sensitive. You will use brackets around your member names if there is a space. You can also use the brackets if there is no space. So you can either use them or not use them when there's no space, but if there is a space, you do need those brackets around. You can identify a member as the dimension dot the member name, or you can just select the member name. If you do allow for dimensions to have to reuse member names and aliases, then you would need to put the dimension dot the member name to make sure that it's pulling the right number. And then you can use current member to return whatever the current member that you're on within the input dimension, and we'll show some examples of those. And then just kind of a general rule that I like to give is to just be consistent throughout when you're writing your rules, just to make it easier to read, and then also to troubleshoot if something were to not be working properly. So what does an MDX report layout look like? You have your basic layout, which is going to be select your dimension. We're going to say access specification, and that's basically your member selection for your dimension. So you're going to select your dimension on your columns, your dimension on your rows from the database, and then your where is where you can slice that data down a little bit more. So the where clause is optional. You can select between 1 and 4 axes, and they are named the columns, rows, pages, chapters, and sections. So on your simplest form, you could select January on your columns from Sample Basic. And that's really just giving you a metadata query at that point. And then your full form would be, an example would be selecting your January on your columns, sales on your rows from your Sample Basic application just for your actual scenario. And this is in its simplest form there. So again, a metadata selection, you could go ahead and just select the members of your year dimension on your columns, and that's going to give you all of your months and your quarters in this scenario. I'm going to be honest with you, I don't know exactly when you might use this, but if you were just trying to drill down and see how things rolled up for a certain number, then you certainly could do this on your columns. But really, you're going to be using this to pull back data. So let's start talking about some of the different members, or how you do your member selection, rather. So you do have the use of your family member functions. So you can say, select the children of my year dimension on my columns. So that's just selecting your dimension there, dot children, a little bit different than how we write business rules and calculation scripts. And then using the substitution variables, we can say select our current month substitution variable on our column. So just different ways to do the member selection. So let's talk a little bit about the different types of functions. I'm not going to spend a whole lot of time on this. I'd rather get to some of the code samples at the end. We do have basic mathematical functions where we're using those symbols, your plus, your minus, your multiply, your divide. You have some number functions. Examples are parent, child, ancestor. Our set functions where we can join across our different dimensions or do an intersection within a dimension. We can look at the children. We can look at member ranges. We can filter that data. Layers refers to our levels in our generations. We can do some work with string data, concatenation, pulling the left and the right. We can do some number functions, the average, sum, max, min. We can work with data. We have our Booleans, which are all going to return that true or false. So we can evaluate something and determine whether it falls into the set or not. And all of those are going to start with is. And then we have our year-to-date, quarter-to-date, period-to-date functions. So looking specifically at those that I think are probably most used or most unique to MDX, you have your hierarchical references, which we are all familiar with from using the application. So you have your ancestor, your cousin, your parent, first child, first sibling, your lag and your lead, various different ways to look at your period, and then again that current member where you can, current member, next member, and previous member, where you're actually looking at the specific member that's being evaluated. It allows you to make the query dynamic and evaluate for more than just one specific member. So different ways to write some of these and produce the same result. You can do similar to what we see in our business rules and our calc scripts and do the parent of our January member with January in parentheses, or we can just say jan.parent. And then if we wanted to specify the dimension and make it dynamic, we could say our year dimension for the current member and give us the parent of that current member. And then that would evaluate for all of the members within our year dimension. One of the other ones that is unique and useful is lag and lead. This uses an index to navigate up and down our hierarchy. Lag moves up a hierarchy with a positive index and down with a negative, and then lead does the exact opposite, where it moves down the hierarchy with a positive number, and it moves down the hierarchy with a positive index and then up with a negative. So current month lag 1, current month lead -1, and current month previous member all have the same result. And then the exact inverse of that, you have the current month lead 1, the current month lag -1, and your current month next member all have the same result. The positive to your lag and your lead is that you don't have to just go one member. So previous member is only going to take you one member. Next member is only going to take you one member, whereas this allows you to use that index to travel up and down that hierarchy as you need to. So I do have an example here where we're selecting, again, that current month lag 1, current month, and then current month lead 1 on our columns, sales on our rows. And we'll see here with our substitution variable set to March, this is now pulling February, March, and April data for our sales. For the set functions we have, these are the functions that return a set. So 3 types of functions. We have metadata-based, database, and then the ones that are just pure set. So a metadata-based function is basically, as it sounds, it's going to use the metadata to derive the results. So again, we have some of those familial references. We have the ancestors, children, the siblings. We can also work with any attribute members we have. We can drill up and down by our layers or by members. We can extract data. We can look at member ranges, relative member ranges. So all of these are looking at the metadata to determine what the set is that we want to return. Database functions use the data to derive the results. So we're going to go look at the data, we're going to analyze that, and we're going to use that to determine what's being returned. So we can do the bottom count, which is, say, the bottom 5 customers, bottom percent, bottom sum, same thing with our top members. There is a case statement, which is very similar to an if statement, as well as the if statement. Filter falls into this category as well, where we can filter our results based on certain criteria. And then we can also order our results using the order function. So again, this is all where it's evaluating data to perform these functions. So here's an example of this one in particular is our top count, but it's very similar when we look at all of our top functions as well as all of our bottom functions. So basically it evaluates and it orders our results. The example that I put here is that we're going to return the sales for the top 5 markets for our COLA product from our sample basic. So here we're putting sales on our columns, and then we're doing a top count of our level 0 members within our market dimension. We want to return the top 5, and then COLA is how we're going to evaluate that because we want to return it for our COLA product. And then I did just throw in a where clause here, so we're only looking at our actual results. And what we get is Massachusetts, New York, California, Texas, and Illinois. The next set I want to talk about, set function I want to talk about, are case and if. So again, these are very similar. They both perform a conditional test. Case allows you to have multiple conditional tests, and an if, you can only do one at a time unless you nest them. This is just my personal opinion. Case, I think, is easier to read, administer, and troubleshoot. There have been, there has been quite a bit of articles out there that talk about how an if statement is better performing than a case statement. I can say from a lot of the MDX I've written that isn't always necessarily the case. I'm not saying case is faster. I'm just saying it's probably not a noticeable enough difference. So I always start with case. And so we do have an example here, same example, one written as a case, one written as an if. You can see the if is nested there and flows down, whereas a case just says when the profit is greater than 10,000, then give me a 4. When it's greater than 5,000, give me a 3. When it's greater than 3,000, give me a 2, else give me a 1. So just a little bit easier to read and follow, again, in my humble opinion. For filter. So filter allows you to return a set that meets the criteria of your search. So for example, if we wanted to return products where sales are greater than 30,000, we could select sales on our column and then filter, again, our level 0 members of our product dimension where our sales are greater than 30,000 on our rows. And this would be the output that we would return. Our order function, order sorts members in your set that you're returning. So you have your optional keywords of B ascending and B descending. The default is ascending. So taking similar to what we just did. So we're going to select our sales on our column. We're going to do our level 0 members of our product dimension. For sales, we want to order based on sales, and we want to do it in descending order. And now we have a list of all of our products with the sales in descending order. So these are functions that are really useful when you're writing the query to make it look the way you want it to. So then we have our pure set functions, and these are going to be where the sets are just defined specifically within the function. You have your cross join, your distinct, your head, your tail, intersect, subset, union. These are all the common ones that I see used. So looking specifically at the cross join, use this very, very frequently. This returns the cross products of two sets from two different dimensions. So take, for example, the formula cross join, quarter 1 and quarter 2 with sales and profit. That's going to bring back quarter 1 sales, quarter 1 profit, quarter 2 sales, and quarter 2 profit. And then if we did, if we made it more dynamic and said, let's give us the cross join of quarter 1 and quarter 2 with the children of our market dimension, now we get quarter 1 east, quarter 1 west, quarter 1 south, quarter 1 central, and then the same thing for our quarter 2. So we can make these dynamic, we can be very specific, but we're going to join those numbers from the two different dimensions that are listed within the cross join. Except. So except returns a subset of differences between two sets retaining duplicates. So if we use the except function with the level 0 members of our product and the attribute of bottle, we're going to get a result that shows us the products that are do not have an attribute of bottle. The generate function, this returns a set formed by evaluating one set in relation to another set. So if we wanted to return the top product for each market segment, we could write something similar to this. So again, I'm putting my sales on my column, and I'm going to do a generate of my children of my market, and then I'm going to cross-join my current member of my market with the top product based upon sales. So I'm doing a top count of my product, my level 0 product members for my sales, and I'm bringing back the top one, and then I'm looking at my children of market, and so I come back with The top product in my east region is cola. The top product in my west is dark cream. Top in the south is cola, and in the central is diet cream. So generate gives you an example to do an evaluation to pull that back. Intersect returns the intersection of two subsets. You can optionally retain the duplicates if you would like. So here I gave the example of doing the intersection of your level 0 members of your product dimension along with that attribute of bottle. And when we do that, we get the result is the resulting list of all of our products that do have an attribute of bottle. We do have some string functions, like I mentioned before. This is just a list of them. Again, we can do concat, left, right. We can do some trims, substring, converting a number to a string. The numeric value functions, most of these should look very similar if you're familiar with the application. So you have your aggregate, your average, coalesce empty, count, length, max, medium, min, rank, sum. All of these should be pretty familiar. Your mathematical functions, again, should be familiar. This is where you can do your absolute value. You can do an integer, power, remainder, round, truncate. A lot of these are things that you also see in Excel. Your date functions, again, just different ways to manipulate your date. I'm not going to go into a lot of detail on those. Your layer functions. So again, this is working with your generations or your levels. So if we did a quarter1.generation.members, we would return all of those members that are at the same generation as quarter1, so quarter 1, 2, 3, and 4. If we did product.generations and the 2 is the index that indicates generation 2 is what we want, then we would return 100, 200, 300, and 400. And then the same thing with our levels. If we did a quarter1.level.members, we would return everything that's at the same level as quarter 1. And if we did a level 0 product, we would end up with 100-10, 100-20, and 100-30. So just different ways to specify our members to produce those sets based upon the layer and the generation, level and generation. Boolean functions, these are those functions that are going to return true or false. They are your case and your if conditional statements. And again, if you look at this list, you notice they all start with an is. So is it a specific member? Is it a specific account type? Is the ancestor something? Is it a child of something? Is the combination empty? So on and so forth as you go through this. It's basically doing that evaluation of true or false, and it does start with the is. So here's a few examples. Is the current member for the year dimension January? Is the ancestor for the current member of market Florida? Is the child of the current member for market East? You can start getting fancy and joining and doing a set and saying, is the set of sales in the current member for year empty? Is the current member for measure a level 1 in the outline? Is the current member for market, does it have a major market UDA on it? And is the current member for product ounces, is it valid for ounces? Does it have that ounce attribute on it? So one thing to note with these Boolean statements is there is no is descendant function. So to determine if something is a descendant of something, you would use your is ancestors function to find the ancestor or the descendant. So this can be read as, so is ancestor member 1 comma member 2 can be read as is member 1 an ancestor of member 2. So example, is ancestor the current member of year January? So that would be true for quarter 1 and year, and that's identifying our ancestors. But if we flip that and said, is quarter 1 the ancestor for the current member of year, now we're finding the descendants. So it's just the order of which you put those two members in as to whether you're doing an ancestor search or a descendant search. You can also optionally include member at the end in all caps, and then that would include, so using our example of is quarter one an ancestor of the current member for year, that would be true for quarter one, January, February, and March. So calculated members and named sets. These are something unique to MDX, and this allows you to calculate custom members or sets within MDX that don't reside within the outline. They are defined only for the duration of the query. They're defined with a with statement at the beginning of your script. They can be used multiple times within a query, and they basically can save you time and lines of code required and execution time. So, and then it's also important to use a solve order whenever you use a calculated member. So what this does is it requires you to not have to have a member within the outline to perform the calculation. You want to calculate something on the fly, you can put it right into your query without having that member in the outline. And it doesn't exist beyond that, it's just for the duration of the query. So a couple of examples of this. So we have display our quarter one actual budget and then the quarter variance. And this is in a situation where quarter variance does not exist within the database. So for that calculated member, that very first line of code defines that. So with the member scenario.quarter variance, I'm saying quarter variance is going to be a temporary member within my scenario dimension. I want to set it equal to the actual minus the budget. And then when I go into my normal select statement, I can say select quarter one actual, quarter one budget, and then I'm referencing that quarter one and the quarter variance calculated member that I just created on my columns. And then I'm pulling my level 0 members of my product dimension on my rows, and I'm doing this just for sales. And so what I end up with is this output right here. Another example of this would be to display the current month and then 2 prior months, and then the 3-month average for sales for all products. So for this one, I'm going to use my substitution variable. So here I'm saying with my member 3-month average, and we're going to say that's in my year dimension, defined as my current month lag 2, so go backwards 2 within my period dimension from my current month substitution variable, my current month with a lag of 1, which is my prior month, and then my current month. So the sum of those 3 is going to give me my 3-month average. And that's a sum, not an average, but you get the idea. So then we're going to select those same exact months along with our 3-month average calculated member that we just created on our columns, and our level 0 members of our products again for our actual sales, and we end up with a result like this. So again, with our substitution variable set to March, we're getting January, February, March, and the 3-month average of those. So another example, so for each market, display the total expenses, sales, and total expenses as a percent of sales for the 3-month average. Just trying to show you how flexible this can be to give you your different pieces. So here we actually have 2 calculated members. We have our same 3-month average, which we just created, and then we're also creating the expense percentage of sales as total expenses divided by sales. And so again, we can do a cross join of our actual and budget with our 3-month average on our columns. And then we can do our total expenses, our sales, and this new expense percent of sales calculated members on our rows for our level 0 members of market. And so what we end up with is now we have in our first column our markets. Our next column is going to be the expenses of sales and the expense percent of sales, and then we have our actual and our budget for the 3-month averages. So next, there's another concept of named sets. And so this is the same thing. Instead of a calculated member, though, we're creating a set that can be used just within the confines of this query. So we're going to, in this example, display the top 5 products for Q1 actuals. So now with that with statement, we're going to say with the set that we're going to call top 5, defined as the top count of the members of the product dimension, and we want the top 5 of them, and we're evaluating sales actual in quarter 1. And then what we can see in our select statement is we're picking quarter one and actual on our columns, and we're picking this named set of top 5 on our rows. And then this is the result where we're getting the products on the column that's labeled Access 1, and then we're getting the sales on our quarter one actual. So something that I mentioned previously that's really important is solve order. So solve order defines the order of execution. This is very similar to what you see in an ASO cube if you're managing an outline in an ASO cube. And basically it just removes any potential ambiguities when it's trying to calculate the query. So it's very useful when there's more than one member, but it is recommended you almost always use a solve order if you're going to have a calculated number. The default solve order is 0. So if your solve order is the same, it's going to evaluate based upon the order in the outline. So to add a solve order to your query, the syntax is simply solve underscore order equals and then a number. So just a quick example here. We have for each market display the total expenses, sales, and total expenses as a percent of sales for the 3-month average. We just did this. Same exact query. We have no solve order on here. So what we see here is, in the results, is that when we look at our 3-month average, it's just summing up the 3 percentages from January, February, and March. So if we go back and we put a solve order on these, which I've highlighted in yellow, I'm saying I want you to solve them in this order. I want you to do my 3-month average first. I'm going to give it a solve order of 10, and then I'm going to do my expenses as a percent of sales by using a solve order equal to 20. And now when we do that, we're actually getting an average instead of the summation of those 3. Another thing that people would want to use when they're doing an MDX query most likely is suppressing those missing values. So to do that, you would use a non-empty clause. And you can use this on any access within the script. So your rows, your columns, your page, your chapter, it doesn't matter. So an example here without using the non-empty. So again, display our actual sales, our cost of goods sold, total expenses, the margin for all products in the New York market. Here would be the query for that. Here would be the results. We see we do have several rows that say pound missing. Not real useful, kind of ugly. So if we come in and we add a non-empty instead of our level 0 products on our rows, you can see the new output here that now suppresses those pound missings and gives us just those rows that have data all the way across the row. Okay, so now that we've talked a lot about these different queries, the syntax, how we write them, there's lots of code examples in here to follow. How do we execute these MDX queries? So you can use MDX, you can use the EAS MDX script editor. You can pass that MDX in a MaxL script, or you can utilize Smart View. So if you're going to use EAS, you would navigate to your editors and find your MDX script editor. It's going to bring up a screen that looks similar to the one on the right side of the screen. And you can see that I've typed in just a real, very simple query on the top part. And when I execute that, I get my results down in the bottom. I do have my list of MDX functions on the left side of that screen, and they're organized by categorical on one tab and then alphabetical on the other, and you'll notice all of those categories are the ones we just covered when we were talking about the different types of functions. So this does give you a little bit of an interface and able to see what those functions that are available, as well as when you pull them in, very similar to a calc script editor where it's going to give you what those inputs should be. Another way to do it is to go ahead and pass the MDX in a MaxL script. So just have a quick example here where you have to log in as the user with your password on the server. You're going to spool it to a text file most likely so that you can see that output. You're going to drop in the MDX query you want to run, spool off, log out, exit, and then I can go to C desktop and I will find a sample underscore MDX text file which has my output in it. In that file. So 2 different ways to run it there. Additional things to keep in mind in the output if you're running it in MaxL. There are some additional commands. You can put your alias on or off. You can set the output display. So this is how you normally want it is numerical, display, fixed, decimal. There are some other options for that. You can alter your session, the alter session to set your decimal precision. The width of your columns, the default is 20. Whether you want your timestamp on or off, and then what you want your error level messaging to be. And your choices are all error, warning, and fatal. Generally speaking, I like to set those to error. You don't want the warnings coming through. So then the third way you can execute a MDX query is through Smart View. So to do this is only an S-based feature. So to do this, once you bring up your panel, you could go to the More, and there's an Execute MDX. It's going to bring up a box on your screen that looks like exactly what you see on your right, and it's just going to be a blank box. This is where I was saying that although you can run scripts within Smart View, you really do have to know how to write them already. So here I put a query into that box, and then once I run that result, it's going to give it back to me in my active Smart View sheet. It's going to be fully interactive. I can do number selections. I can drill into it. It retains options. If you suppress your missing values with a non-empty in your query, it's going to maintain that for you. So it's just a way to get a prettier output and get it within Excel. So that is one option to execute within Smart View as well. And then the last little thing I put in here was just about tracking your MDX queries if you were having issues. So you can track your MDX queries that are run against your S-based database. You would have to go into your S-based config file and add a row, and it should be trace MDX, and then put your app name and your database name. And then the results are output into a file that's named MDX tracelog in your Arbor path. And then the log does contain a timestamp of the query completion and the elapsed time of the query. It does not contain failed queries, so it only contains those that ran successfully. So here is an example of what that output would look like within that file. So real simple, it's just what you executed, when you executed, and how long it took to run. But again, it is only those successful queries. So again, that was the content. Hopefully that can get you guys started with writing some MDX queries. Hopefully it's useful. Tried to include a lot of different code samples, although for you to be able to go back and reference. And I want to thank everybody for their time today. I appreciate you joining us, and I will hand it back over to Greg.
Thank you, Jennifer. And thank you all for joining us today for the webinar, Mastering MDX for Analytics and Reporting. If you have any questions, please don't hesitate to contact us. Jennifer's and my contact information are on display on your screen. Thank you again for joining us, and have a great day.